as we continue on with our polynomial functions, one thing that's interesting about them is that we can predict what we call end behavior just by looking at the equation. Okay? Now, end behavior tells us how the graph will behave when x is very, very small or very, very large. Okay, so in other words, on our graph, as we go out to larger and larger x numbers, from 10 to 100 to 1,000 to 1,000,000, what is happening on the far end of the graph? And when we're dealing with polynomial functions, as we get to really, really large x numbers, way out on the right side, the graph will either be zooming up or it will be dropping down. One of those two extremes. It's either going to go up or it's going to go down pretty quickly, zooming up or zooming down. On the left-hand side, as we get smaller and smaller x numbers, -10, -100, -1,000, as we get to smaller and smaller x numbers, the same thing is going to happen. The graph will either zoom up or zoom down. Okay? End behavior is what we talk about when we say, hey, what's happening on the far right and what's happening on the far left? Is it going up or is it going down? Okay? Now, we can look at an equation and know what's going to happen, okay? And you kind of already know this, you just don't realize that you know this. If you think about the function y equals x squared, you know that that's going to be a parabola, and that because the a value, the number out in front, is a positive number, in this case 1, you know that the right end is going to go up and the left end is going to go up. You knew that the end behavior was both ends going up. You knew that if we had y equals -x squared, that would be a parabola opening down. You already knew that the end behavior would be both ends going down. And the reason you knew that was because we had a negative out in front. Okay, so here's what's going to happen. If you have an even exponent, whether it's x squared, x to the 4th, x to the 6th, x to the 8th, what have you, whatever the even exponent is, both ends are going to do the same thing. Either both ends are going to be going up or both ends are going to be going down. Okay? How do you know which one it is, both up or both down? You know that by looking at the number out front. If the number out front is a positive number, like a +1, both ends will go up. If the number out front is negative, like this one had a -1 out front, both ends will be going down. Okay, so let's look at some other examples here. There's our x squared example, isn't it? Had a positive number in front, a +1, and an even exponent, so both ends were going up. Okay? They didn't give us a -1, but if we'd had a -x squared, both ends would be opening down. Okay? So notice that this one right here, both ends are going up. We do not know what the exponent was. We do not know if it was x to the 4th or x to the 6th or whatever, but we know there was a positive number out front. Now, just so you know from experience, I do know that the exponent here would have been 1, 2, 3, 4, 5, 6. I kind of count the little segments. I went down, up was 2, down was 3, up was 4, down was 5, up was 6. This one was probably an x to the 6th. Now, it could have been an 8 or a 10 or a 12, but it was at least an exponent of 6. Okay? This one went down as 1, up as 2, down as 3, up as 4. I bet this one was an x to the 4th. Could have been a bigger even exponent, but I bet it was an x to the 4th. And it also had a positive number out front. Could have been 8, 8.5, could have been 9.3, pi, any positive number out front. Okay? When both ends were going down, I know it started with a negative number, -4, -7, whatever. Up is 1, down is 2, up is 3, down is 4. I bet this was a negative number out front and then an x to the 4th. Up is 1, down is 2, up is 3, down is 4, up is 5, down is 6. I bet this was an x to the 6th with some sort of negative number out front. Okay? So when you have an even exponent, both ends match, either both up or both down. The positive coefficient, both ends were up. If there was a negative coefficient out front, both ends were down. Okay, well, what if we have an odd exponent, like x to the 3rd? Well, you already know a little bit about x to the 3rd as well. X to the 3rd, if you remember, the right end went up and the left end went down. We practiced that as one of our parent functions in the last chapter. Okay, so when we have an odd exponent, one end will go up and the other end will go down. Be one of each. Okay. Now, how do you know which end does it? I always think about A for attitude. Okay. So if the A number is positive, it goes up on the right, and that means the left end is the one going down. If your A value, your number out front, is negative, then it would be reversed. It would be the left end going up and the right end going down. And sometimes people get those mixed up. Wait, which end is the positive? Which end is the negative? So I always think the sign is how it ends the day. So if I had like a 4x to the third, my 4 is positive. So this graph will end the day. The right edge will be positive. The right side's going up. It might be negative at the start, but it's positive at the end. As the day goes by, things were looking up. If I had a negative 4x to the third, exponent is odd, so one end is up and one end is down. Since there's a negative out front, it must end the day going down, which meant it started the day going up. Okay? So if I look at this one, up is 1, down is 2, up is 3. I bet this was an x to the third, and it must have had a positive number out front because it ended the graph, it ended the day going up. Up is 1, down is 2, up is 3, down is 4, up is 5. I bet this one was an x to the fifth with a positive number out front. Okay, if we count this one, 1, 2, 3, 4, 5. I bet this one was an x to the fifth. It ended the day going down, so I bet it had a negative number out front. Okay, so those are just some little tricks that you can kind of use to help you figure out what was happening in your graph. Okay, so let's look at some other examples here. They've given us some equations, and they want us to determine the end behavior. What's happening on the far right edge and the far left edge. So we're going to want to look at that first term. Make sure it's got your biggest exponent, so x to the fifth. That exponent is odd, so that means the two ends are going different ways. One end is up and one end is down. They're going different ways. Okay, how do I know which end is up and which end is down? Well, it's a positive number in front. It's a positive 1. So that positive means the right end is the one going up. Okay? So if the right end's the one going up, that means the left end is the one going down. So left, I'm going to write this way, down on the left and up on the right. Okay? And we can always graph in a calculator to verify. So if I go to y equals and clear out whatever I have in there, x to the fifth minus 5x to the third plus 4x, and I graph it in my calculator. And sure enough, the left edge is going down and the right edge is going up. And if you wanted to count your segments, 1, 2, 3, 4, 5. So I was kind of right about that as well. So there's x to the fifth. There were kind of 5 segments. Left edge was down, right end was up because of our positive coefficient. Remember the coefficient's number out front. Okay? This one's a little different, okay? This one is in what we call factored form. Now, if you want, you can write out x plus 1 times x plus 1 times x plus 1, FOIL it out, FOIL that result with the x minus 5, then distribute the negative 2. You can do all that if you want to. I don't really want to. It's a lot of work. But I know that if I FOILed it all out, I would end up with an x to the third from this one, and another x when I FOILed it with x minus 5. So I would end up with an x to the fourth plus some other stuff. There would probably be an x to the third and a 2x and a minus 3 or whatever. I would have some other stuff. But I would end up with my biggest exponent being x to the fourth. And there would be a negative 2 in front of it. So I would have negative 2x to the fourth plus whatever else was involved. Okay? That is all I need, that lead term, to decide on my end behavior. Notice that my exponent here is an even number, so that means both ends match. That means both ends are up or both ends are down, whichever one it is. There's a negative number out front, so since both ends have to match, it's got a negative attitude. They're both going down. So I'm going to make a note, both ends down. Or you could say down on the left, down on the right. I think your homework may ask you to say, hey, as x approaches positive infinity, that means as you go to the far right, the graph would be going down. That means y would approach negative infinity, to say y is going down. On the left edge, as x approaches negative infinity, as x gets smaller and smaller and smaller, that end is also going down, so you would choose from the drop-down menu y approaches negative infinity. I think there may be a homework question that asks it that way. Okay, so in my calculator, I can verify. I can type -2 times x minus 5 times x plus 1 to the third. And when we graph it, sure enough, it's going down on the left edge and down on the right edge. So we were right to predict that both ends would be going down. Number 3, again, this is in factored form, but if I FOILed it all out, I would have an x to the third times 2 more x's, that would be x to the fourth, times another x, I'd have an x to the fifth. 3, 4, 5, 6 when I add up all those exponents. And because this one has a negative out front, when I FOILed them together, I'd have a negative out front. There would be some other stuff with it, but my first term would be negative x to the fifth. This exponent is odd, which means the ends go opposite ways, one up, one down. We just have to decide, is it the left or right going up, and is it the left or right going down? We're not sure yet. Well, because we have a negative number out front, a negative coefficient, that's like a -1 is our coefficient, that tells us how it's going to end the day on the far right edge. It's going to end the day going down. So this one must be down on the left. I'm sorry. It's ending the day going down, so that's down on the right. And then the left end would be the one going up on the left. And we can verify that. We can go to y equals -x to the third, parentheses x plus 2 squared, parentheses x minus 3. And, oops. Oh, I see my mistake. Sorry about that, y'all. 3 plus 2 is 5, plus 1 was 6. My apologies, y'all. That exponent was a 6 there. 3 plus 2 is 5, plus 1 is 6. And when we have an even exponent, the ends match. So my apologies. Both ends match. So since it was negative out front, it's down on both ends. Down on the right, down on the left. And sure enough, that's what we saw in our calculator. It's down on the left and down on the right. My apologies. I rushed through that. Okay? So I'm going to say both ends down. Okay? Fourth one, they've already given it to us all FOILed out. We didn't have it in factor form. They had it in multiplied out form. So we're just going to look at that first term. Our exponent is even, which means both ends match. Just like this one, we had an even exponent, x to the 6, so both ends match. And our number out front is positive, which means it's going to be going up. So both ends are going to be going up. And if we graph that one in our calculator, 3x to the fourth minus 11x to the third minus 2x, minus 3x squared minus 6x plus 8. So I have that typed in right? Yep. And when I graph it, sure enough, the left end is going up and the right end is going up. Notice this one doesn't seem like it has the 4 line segments. Remember how we talked about the little pieces here? It doesn't seem like it has 4. And the reason for that is that based on the picture, there could be a higher exponent than what the picture seems to show. The picture seems to only show 2 pieces, down and up. So in the real equation, it could be higher than that, but it will have to be an even number. Since both ends are up, we know that it had to have an even exponent. Okay? But I just wanted to point that out as well. Okay, we will apply some graphing stuff here in just a second in our next video.